Welcome to this full-length deep dive into neural radiance fields, or NeRFs, one of the most exciting breakthroughs in 3D computer vision and scene reconstruction. NeRFs allow AI to generate realistic 3D views from just a few 2D images. They've revolutionized how we capture and render 3D scenes. At its core, a NeRF is a fully connected neural network that learns a continuous volumetric scene representation. Instead of using explicit geometry, it models scenes as fields of color and density, allowing photorealistic view synthesis. Here's how it works. You input a set of 2D images from different camera angles, along with their camera poses. NeRF learns a function that maps a 3D coordinate, x, y, z, and a viewing direction, VF, to color and volume density. To render a view, the model shoots rays from a virtual camera and samples points along each ray. It aggregates colors using volume rendering. Compared to traditional 3D reconstruction techniques that rely on point clouds or meshes, NeRFs offer higher visual realism, continuous scene representation, and smooth interpolation between views. A standard NeRF is trained from scratch for each scene, but newer models like Instant-NGP, mip-NeRF, and NeRF++ enable faster training, higher resolution, and dynamic scenes. Training typically requires 2,100 images of the scene, known camera intrinsics and poses, from tools like Colmap, and optimization over many ray samples per pixel. NeRFs use positional encoding to allow the MLP multi-layer perceptron to model high-frequency variations like edges and textures. Recent developments include Instant-NGP, NVIDIA, trains in seconds using multi-resolution hash encoding, mip-NeRF, handles anti-aliasing and mip mapping for smoother renders. NeRF in the wild generalizes to unconstrained photo collections, and dynamic NeRFs capture scenes with motion over time. Use cases include AR/VR, create immersive environments from real scenes, gaming, scan environments or characters in 3D from images, film, relight, and animate scenes without expensive scanning rigs, and robotics, use NeRFs for mapping and scene understanding. Let's look at tools and libraries. NeRF Studio, a user-friendly pipeline for training and viewing NeRFs. Instant-NGP, fast and memory-efficient implementation by NVIDIA, and Colmap, structure from motion tool to get camera poses. To render a scene, NeRF casts rays through the image plane, samples points along the ray. The MLP outputs color plus density per point, and uses alpha compositing to blend the colors along the ray. This ray marching and compositing mimics how light behaves in the real world. Recent research also combines NeRFs with language, text to 3D, neural rendering, and generative models, allowing creation of entire 3D scenes from text or sketches. To summarize, NeRFs are neural networks that model 3D scenes from 2D images. They synthesize novel views with high realism using volume rendering, and new methods enable real-time rendering, dynamic scenes, and editing. Thanks for watching. Subscribe if you'd like a follow-up on Instant-NGP, NeRF training pipelines, or building your own scene capture rig using open tools.